Welcome everybody to our partner webinar. This session today is brought to you by Scale Computing, and we'll be joining our speakers briefly, but first I do want to cover a few instructions on our webinar console. First of all, this session is being recorded, so if you step away or miss any portion of today's session, you'll be able to view it on demand with a link that we'll send to you in about a day. Also, this session is interactive, so we want to get your questions in so we can cover that throughout the session and at the end. And you can use the Q&A widget on your screen to get those on our side. We'll get to as many as we can, and if we miss any, we'll follow up with you after today. We also have a list of handouts available, so look for that right underneath the slides, and you can get some more information there. Also, bring up the attendee chat if you'd like to start a conversation with your fellow IT pros. That icon is located at the bottom of your screen, second from the right. And again, just enjoy your time there, but please follow our community guidelines. So with that, I'll start with our introductions. We have Mike Lyon, Product Manager at Scale, and then we have Brad Violand, Product and Brand Manager. So with that, I'll hand it over to you to get started.
All right. Good morning, good afternoon, everyone. This is Brad Violand. As stated, I am a product and brand manager with Lenovo Datacenter Group for North America. And I'll be kicking things off here, and then we'll pass it off to Mike Lyon here shortly, and he will talk to you a little bit more about the actual Scale HC3 solution. So, kind of kicking things off, let's just take a quick look at this partnership that Lenovo and Scale are continuing to invest and grow in. So you can see Scale is a relatively young company, going back about 11 years old now, and they are definitely growing in the hyperconverged space, winning a lot of awards in that particular market, which we will go into a little more depth towards the end of the presentation. And then really the Lenovo partnership started to begin about 2 years ago, a little bit more than 2 years ago, where we did a meet in the channel type of approach, and now we're really kind of kicking it into a higher gear through what we call our on-demand program. So basically that allows not only Scale to sell their solutions, of course, but it also now enables the entire Lenovo direct and partner community to sell the HC3 solution as well. So today we're here to talk about how Scale HC3 is really a good fit for Edge and IoT. So kind of stepping into that realm, let's just take a quick step back and kind of define what edge computing is. A lot of folks have different definitions of edge computing out there. I borrowed this from one of the co-founders of Scale. What is edge computing in a very simple definition? It is when you are running critical applications or need some type of compute power outside the four walls of your data center. So, if you think about the paradigms that we've seen throughout computing history, starting with everything centralized and having mainframes with, kind of these dumb terminals at the end. Those were your quote-unquote edge devices. Then we saw more compute. Now we're moving back toward the cloud. But we're still starting to see the need for compute devices, computing power out at those edge sites. And really a lot of that is being driven by the Internet of Things. So looking at the Internet of Things and edge computing and how they relate, right? So as everyone knows, the amount of IoT or Internet of Things devices is increasing. You look around even your home, and the amount of products that you have on your Wi-Fi network at home has probably grown exponentially over the past 5 years. It used to just be, you had a laptop, maybe a tablet, and a couple phones on there. But now you have light bulbs, you have thermostats, you have leakage sensors to detect if you have a water leak somewhere. Same thing is happening in the enterprise space, right? Where, manufacturing, you have flow monitors and temperature controls, and retail, you have checkouts and live devices that are monitoring, if you're in a grocery store, maybe freezer temperatures and things like that. Just explosion of devices, right? And all of those devices are going to generate data, right? Data that something needs to take and process that data to make some sort of useful information that could be consumed from it. So that's really where we're seeing edge computing play a large space, is we put that compute power very close to those edge IoT devices, and we kind of do a first pass. And we look at it and say, okay, what is the data that's really important that I want to maybe feed up into my artificial intelligence or augmented intelligence system? Maybe I have a big data warehouse that I'm going to feed this to. And a lot of times those AI systems and big data warehouses aren't going to be concerned with just the nominal everyday data, right? If the temperature in my freezer in the back of my supermarket is fine, don't really care, right? As long as it continues running. When I start to care, and what my systems are going to learn from, is when the anomalies start to occur, right? That's when I want to be notified and learn maybe, what type of characteristics led up to that, right? So I can plan for that in the future and minimize any losses or downtime. So the edge compute is really what's going to filter that out and allow the AI system just to absorb the data that it's really going to benefit from. So the edge compute, why we particularly choose this method for that kind of first pass over, say, uploading your data to the cloud or sending it directly to a centralized data center where your AI or big data type of solution may live, is partly there's just too much data, right? There's this explosion of data. If you were to try to send every piece of data from all of those IoT devices to your main data center, you're looking at constraining your network bandwidth, increased cost, things of that nature. At the same time, with resiliency, you may have data that needs to be acted on at a relatively instant type of timing scenario, right? So trying to send it back to a data center or up to the cloud a lot of times will introduce latency that maybe your type of solution just can't be exposed to, right? And sometimes it's due to laws and regulations, right? Let's say, your main data center lies in another country versus where your IoT devices are collecting data that you want to process. So maybe you need that edge compute so that that data is processed on premise in that country before it is sent elsewhere. So again, as you move the IT to the edge with edge computing, a lot of challenges become apparent, right? You're starting to spread your IT resources out to multiple different geographical sites. You don't have a lot of on-site resources in terms of people. You have more systems that require more training. You have to think about deployment, timing, and how you're going to deploy all of those, right? When you're first starting out, and then how do you maintain it going forward, right? If you have edge compute at 70 manufacturing sites worldwide, what type of system maintenance plan are you going to have when upgrades or security patches need to be done? Scheduling maintenance windows, interoperability. Maybe you have different hardware or different equipment at those 70 different manufacturing sites. How do you interface with all of that, right? So downtime and people really become some of the two biggest concerns when we look at edge computing and what IT folks are really going to be worried about. So that is where Scale Computing HC3 comes in and is a really awesome solution for edge computing. So with that, I'm going to turn the floor over to Mike Lyon from Scale Computing, who's going to talk about why HC3 is great for this type of solution.
Thanks, Brad. Hope everyone's enjoying the day, enjoying the webinar today. On this slide, what I really want to look at is on the left, the adjacency to edge computing and IoT. And if we looked at the slide a few slides back where we talked about why edge computing suddenly began to matter, it had to do with the explosion of IoT, right? With thousands and hundreds of thousands of data gathering devices in remote sites, we needed to do something to bridge the computing gap, if you will, between those remote sites and those data gathering points to where it was traditionally being sent to cloud or large data centers, right? And that adjacency of the edge and the IoT is really where we've been able to work together with Lenovo to create a pretty amazing product. And looking at the larger HCI market, it all is trending edgy, if you will, simply because of the innovations that are surrounding it. So today I just want to reconcile a little bit in depth of why we're here today and how Scale and Lenovo are bringing to market some really unique innovations around the edge, but also how edge computing is transforming HCI into an even more efficient paradigm, more so than it already is, and how those efficiencies are actually going to start to percolate up and affect today's purchases, today's infrastructure. So what is scale computing? So what we provide is a hyper-converged solution. It is an on-premises unified platform that integrates software-defined storage, networking, HCI all into one stack. So you have one unified control plane. There's no separate licensing because we aren't going to be using VMware or a third-party hypervisor. It's all going to be built in. That simplifies your life. It simplifies everyone's life, and it's a lot less expensive in the long run. But most importantly, we wanted to build a stack that was fault-tolerant and self-healing. So we didn't want to have to become experts in clustering or object storage or understanding how those interact with the hypervisor. We wanted to have that all automated. Really a simple design for any IT admin to be able to manage your infrastructure, understand that everything is working, and focus more of your time on hopefully fun pet projects rather than just keeping the lights on and everything up and running. And because of the design, we're able to scale and right size for the environment. So you don't have to worry about in your initial deployments, am I buying enough to last me for 3 years if something's going to change? Am I going to have to rip and replace this? Scalable infrastructure is in our namesake, and that's obviously important to us. Along with having things like backup and DR as a service available. Again, all these built-in, agentless, viewed and managed from a single pane of glass without having to open up additional consoles or get different vendors involved, whether that's from licensing or support or even just figuring out how are they all going to be compatible together. And that's really the big benefit of HCI is it puts that all under one pane of glass. And for scale, we become, one throat to choke or one pat to back to pat, depending on how you look at it. But with HCI, it's simplifying and it's minimizing the amount of components that you have to worry about managing, really to just deliver a platform that is as simple to use as the private cloud, where I'm just deploying applications, I'm deploying VMs. I don't care what's going on underneath. I want to know that it's autonomous, that it's self-healing, and it's going to give me all my resources in a highly available fashion. So as we were trying to build out and realize, look at what the actual needs of the edge were, we started to realize that there were some, three something that's smaller, maybe is fanless, can work in different, more ruggedized environments. Really require that we have different form factors outside of the traditional 1U. The 1U server is probably going to seem like a monolith at some point. And if you look at Lenovo, even to me, the SE350 seems big compared to some of their nano devices, and that's a half width, half depth server as it is. But the form factor becomes important, especially in power. That's something that has a quantitative cost to it, as well as having to deal with the wiring for it. And I'm going to skip next to the bottom one, speaking of wiring, is networking. With any HCI stack, and every traditional data center deployment of your infrastructure, you're having to compensate for providing a networking layer there, because that's never going to be just built in, right? There's always got to be a switch there, specific to your data center stack, whether it's for data replication or there's actual access. The networking layer drives up the overall cost of any solution. It's requiring additional port density in your switches. Those have to be managed. Those take more power. It's just another step to the stack that we wanted to figure out how can we eliminate this, or at the very least make networking as plug and play as possible. And then as you grow, and if you think about management at scale, going beyond the 20 site, I guess that's how I define edge scale, 20 sites and beyond. What does it look like managing those applications, managing your workloads and clusters? Does that become an administrative nightmare, or do you have the tools to manage those in place? So these are just three of the biggest challenges that we wanted to talk about. And the networking one is really unique, and I'll talk in a few slides about how we've tackled some of those challenges. So if you look at the traditional server deployment, and I'm just using one server in this example, but if you wanted to throw three of these together for a example HCI cluster, if you've got 64 gigs of RAM, a typical server workload or build out, just to start up and run a competitive HCI solution, what they've done is they've basically virtualized the SAN, as that was the most complicated, cumbersome part of the stack. But in doing so, you have to carve out, a fairly specific amount of resources to run that virtual SAN, to run that VSA or that virtual storage appliance. So really the resources required just to get to the point where I can turn the lights on and run a VM, it's taking 24 gigs. Now, in larger data center type deployments, especially where hosts may have significantly more than 64 gigs of memory, that's perfectly fine, because that's not a significant percentage of the overall available resources. It's unnecessary overhead, but it's necessary for others to want to run VSAs. But at scale, we didn't really see that as necessary. One of the unique things about our platform, especially as you start to scale down, is at the most, we're going to consume 4 gigs of memory. And that's for systems running 32 gigs and up. And 4 gigs isn't a whole lot more than running a couple of Windows servers, right, with that memory overhead. So if you think about shrinking down form factors that are going to have lower amounts of resources, but they can still be clustered together for fault tolerance, with 32 or 16 gigs of memory, how other solutions actually wind up getting deployed really becomes incredibly inefficient. At 32 gigs, you got 8 gigs of memory free, so maybe you can run a pair of VMs. And if you wanted to go onto a smaller system, you're completely out of luck. So unless you wanted to run, direct instances of your operating system and run these as individual servers, you really couldn't do anything for a hyperconverged edge solution. So again, just to turn the lights on, taking 24 plus gigs of memory is really, it's not going to work. Enterprise form factors and solutions, unfortunately, don't scale down. And that's really why Lenovo and Scale are working together. As I say, we're winning the race to the bottom, which is, finding a way to build smaller and more efficient form factors, because we've already proven that we can grow larger, but addressing the edge and growing down is really a unique feat. So, compared with others, HC3 Edge can operate with less than 2 gigs of memory. Again, think about what Windows chews up, or even like the latest, I don't know about Android, but iPhones, the latest models have 2 to 3 gigs of memory depending on the model. That's just to run a phone. Obviously, they're doing a lot, but just to demonstrate how lightweight we are. Again, even in the nano footprint where you've got 8 gigs or less, that's still enough to run a pair of VMs, containerized workloads, and really embracing the edge with the nano term because it's even lighter weight. So when we can get down to 1 gig of memory on those smaller form factors, again, this is just proof that scaling up is important, but scaling down is what we need to do to address the edge, the requirements of the edge marketplace, right? We saw earlier, form factor was one of the biggest challenges. So we've already got the operating system, and HC3 Edge is already built to address those needs. And HC3 Edge is the same HC3 Hypercore stack, and it's everything that's designed for the data center, but it's available for the edge. Any x86 VM, any container workload, it's really designed to be as fault tolerant and as user friendly as possible. and those two concepts don't always go hand in hand. But again, you're not having to learn how to set up a cluster and how to set up availability groups. You're configuring your workloads and your resources. Our efficiency is, again, unmatched, and you can run on an incredibly small footprint and grow up from there. There's not additional costs for having to buy management overhead software or specifically licensing the hypervisor. This is all just built into the software layer. Again, whether you're using traditional workloads, containers, anything is going to run because we're just really wrapping a traditional hypervisor underneath. And we can license that in a flexible fashion as well. If you're looking for multi-site deployments, those can be priced based on VM, based on core. There's a lot of options there, as well as subscription options. Since the CapEx versus OpEx model is continuing to be a popular argument, but some of the specific things that we've added into the software stack are the ability to do easier deployments. Zero touch, where you could plug and play remote nodes and they can download the configuration. They can, pull down any required VMs. So adding a lot of automation and orchestration into the Edge suite, along with some enhanced networking changes, and I'll show those in just a few slides. And then again, we've got a very robust multi-site management tool. So if you've got, really 20 or more is great, but even if you had 4 or 5 or more, that's a great dashboard tool that we have. Again, giving you visibility, change management, orchestration, and remote health monitoring all in a single view. So looking at some of the Edge form factors, the one in the middle is, I referenced earlier, I talked about the SE350, that seeming large compared to some of the others. You can see on the far right, those are the nanos. We did some demonstrations with those at Tech Field Day, and those started 4 gigs of memory. We did a demo running on one of the 4 gig nodes. And those have all sorts of connectivity options. And that's what's unique, again, about some of the Edge form factors is that they tend to be a little bit more flexible in networking because it's not necessarily the traditional data center type deployment. And again, once you get down to the smaller form factors, the resources become a little bit more constrained. But realistically, when most of the remote sites are running 3 or 4 VMs at the most, and just doing small compute work, feeding that data back elsewhere, you don't need the enterprise size footprints anymore. Again, however, the SE350 does have a lot of flexibility in there. But again, if you look at the mid-range tiny form factors, the capacities they have are really pretty realistic for what most of us are doing. If you think about an edge workload anyway, or a small office, a data center, print server, a couple of VFS replicas, and everyone's shifted off their email anyway. So, I would joke that I think Office 365 and Gmail also help to enable edge transformation because we don't have to run giant mail servers anymore. I talked about networking, and this was probably one of the biggest changes we made to the product to accommodate the edge form factors, especially since many of those devices tend to only have 1 or 2 built-in NICs. Obviously, there's not a PCI slot where we can throw another one in there. So we needed to figure out how we can redo our networking and provide connectivity over 1 or 2 ports, as well as eliminating the traditional data center switch. In traditional data center networking, everything revolves around, virtual switching and physical bridges, on the nodes for virtualization. That's how hypervisors have done things for decades. And then we use VLANs to segregate and isolate the traffic. Just go ahead, duplicate everything so we have redundancy, and then we're done. And that's how everything has been done for the last 15, 20 years. And we always wanted to make sure, especially for virtual deployments, that we had a special, separate, dedicated either physical switches at the low minimum, or a VLAN for your storage traffic or anything that was spinal cord vital. But this doesn't work for the edge form factor. We weren't able to just take what was in there today and shrink that down to work for the edge. Because the networking has its own set of challenges that are at the edge. And why doesn't that work? Well, number one, if you have to throw a switch in every site, which is They're expensive. You're probably going to have to buy 2 of them for redundancy. It's an additional failure point, an additional management point, an additional power consumer. It's another U in your rack, another thing to manage. Do you have enough ports to uplink that to your core, et cetera? The list goes on. But extending the basic data center methodology just doesn't work because it doesn't scale down. And software-defined networking helped solve some of those data center challenges. So it made sense to start solving problems at the edge with the same methodology. Again, smaller ports or smaller devices have fewer ports, and some of them have different connectivity options like Thunderbolt. But beyond just the physical hardware, how do we still provide the same level of management with VLAN functionality with network isolation? Because again, the most expensive thing at the edge outside of the hardware is going to be switch ports and data access. So we need to figure out how to simplify that and how to overcome that challenge. So our networking stack, I guess, within HCI, within HC3 Edge Fabric. So this is it's a fabric that basically extends the traditional VLAN topology and integrates it directly into HC3. So you've got a new entirely transparent SDN control plane that can completely modify and change topologies specifically at the edge, because you can create topologies and deployments that don't have any requirements on a backplane switch or even a unified switch to connect them together, basically allowing you to build a direct connect / ring style topology where you're extending that topology, pulling the VM and host networking into a single stack. And that's what HC3 Edge Fabric is doing. And perhaps most importantly is it's eliminating the backplane. So using integrated connectivity, not just Ethernet, but things like Thunderbolt 2, simplifying that layer 2 topology and building out the underlying complex networking into a simple UI. So you don't even have to go and learn another SDN control plane or subscribe to a cloud networking service. It's providing that functionality built into it for you. And again, not in a separate UI, not with a separate console, but just as a native part of HC3. So this gives us a lot of options. This gives us the ability to create some really unique topologies. So using existing switching, we can create internode links that way. That's a traditional HC3 deployment like you'd see on top. Not redundant links. Or again, getting rid of the switching, we can now directly connect the nodes to each other and create a fault-tolerant topology. It's the same highly available stack, but it's without the additional networking hardware. So it's without having to require a switch. Specific to the edge, this is important, a real important step in removing unnecessary hardware and getting rid of the networking challenges by just getting rid of the switch and making it optional. Because you can still use switches, but you can also directly connect the nodes. Again, with both Ethernet and Thunderbolt 2, you can create a full fault-tolerant, extremely high-speed, low-latency network that provides redundancy and fault tolerance, as all interfaces are available as uplinks to the switch. So they're all available to connect both to one another as well as to the uplink switch. So if you lose one, or if you're even losing 2 uplinks disconnected, you still have a fully functional stack, as the distributed bridge mechanism that we built in is still fully fault tolerant. So you can connect the nodes to each other. Basically, that's the simplified way of saying of what Edge Fabric is doing, is it's allowing you to create a unique ring topology, but without having to do anything with switching, without having to do any port configuration. This is all just done transparently by HC3 on the back end for you. So it's a fairly robust overall networking platform, but that's just the highlight really of the entire platform, which is designed to run on smaller form factors, was designed for the edge, was designed to overcome those objections that we noted, not just the form factor and networking, but also the cost. Obviously, as you get smaller, these become less expensive. And even if you think about what you might be doing today, and what is an edge defined as, well, that remote endpoint doesn't have to be a physically distinct site that's 50 miles away. The edge can be within your building. maybe where you once deployed departmental servers, you can drop in an edge cluster, and they're getting fault tolerance instead of just a standalone server. So the edge, as however you want to define it, if it's outside the four walls of your data center, you could still have that type of deployment within your own organization. So just something to think about. So with that, I'm going to hand this back to Brad.
All right, great. Thanks, Mike. So some pretty exciting stuff that's going on at Scale Computing, as Mike said. So, personally, I'm really excited about the just how small these devices are getting. So, next week in my stocking, if a couple of those nanos fall in there for me to use at the house, Mike, I'd appreciate it. So, so one of our case studies that we've done that has been very, very successful in the edge solution place is with a company called Del Hayes. So if you see their logo up there at the top right, those of you in the East Coast and Mid-Atlantic states may recognize that as the Food Line logo, which is their U.S. subsidiary. So Lenovo and Scale Computing partnered on a project for Del Hayes over with some of their European operations to replace some aging hardware in some of their grocery stores over there. And of course, as many of you know, each grocery store is not going to have a data center in it, right? It's going to have, at most maybe a closet, or in many cases, just a spot in the back somewhere where they can put a few pieces of equipment. And that equipment is responsible for running a large number of things throughout the stores, right? So, not only things that you would commonly think about like point of sale and self-checkout and things of that nature, but also things like store security, again, IoT devices, monitoring things such as scales, freezers, cooking devices in certain departments of the store. A lot of different things that they already needed, but they also wanted to implement some new technologies that would really drive and improve the customer experience, right? So one of the cool things that they launched over there that's helped the shopping experience that is driven by the solution that's in each store is customers on their mobile device can open up an application when they arrive at the store, and it will automatically detect what store location they're in. And if they've gone ahead and put their shopping list in the app ahead of time, it will automatically rearrange their list in the order of which they'll walk through the store. So some pretty cool stuff that's been enabled by the HC3 Edge solution with the partnering with Scale and Lenovo. All right, so let me take just a few minutes and just kind of talk about why Lenovo Data Center and why Scale Computing has chosen to partner with Lenovo for the hardware platform. So many of you probably know Lenovo and our flagship product line, which is our ThinkPad laptops. But some of you may not realize that we are also a full data center solution provider as well. So the same type of reliability and innovation that goes into our ThinkPad and all of our consumer products is the same type of quality and innovation that you're going to see in our data center products as well. So we have a global reach. Our data center group is based in Mooresville, North Carolina, which is where I sit. But we have operations throughout the world that goes everything from engineering to sales to help our customers wherever they may be located, realize intelligent transformation within their data centers and outside their data centers. Quality and reliability. Really, for us, it starts with engineering. Everything is tested and proven to the highest standards. In fact, I have a slide coming up next. We'll talk a little bit more about how our reliability ranks in the industry. Performance. This is something that we take very, very seriously, but we do so not wanting to sacrifice any of that reliability, right? So things like drivers and firmware, we take a few extra steps in engineering so that even though under the hood we may be using the same components that some of our competitors use, we go ahead and tweak anything that we can to make sure that we are squeezing the full amount of performance out of the components and passing that on to our customers when they are implementing these solutions. Security. So we, frankly, are probably the most secure OEM vendor out there these days, and part of that is due to some of the regulations that we have to uphold, but also a lot of it is self-imposed. So things like our firmware development takes place in a secure facility here in Morrisville, and there are only 6 folks in the entire world that have access to that, and we employ such things as dual-factor authentication to get in the room. There have to be 2 people in the room at all times. Everything is digitally signed. Every time that one of our systems goes through its boot up and post-process, those digital signatures are double-checked to make sure nothing has been tampered with. And, you know, it also extends into our manufacturing. We are really the only OEM out there that owns their own supply chain, and we own our own factories. So everything is controlled from the suppliers all the way to delivering it to the customer's site for installation. Return on investment. You know, everybody is wanting to get high return on investment and speed time to value. So we really emphasize easy integration, flexible design, scalable products, and easy to service products that are going to really, you know, last you a number of years in your data center or in your edge compute environment in this case. So speaking of reliability, this is just a look at how we stack up. So this is from our friends at ITIC, which is a independent testing outfit. And if you see there, we have ranked #1 in x86 server reliability for the past 6 years. So you can see there just how we stack up to some of the primary competitors out there in the marketplace. If you actually expand this and look beyond just x86 server and you look at the entire enterprise compute market, things like mainframes and stuff, IBM mainframes are the only thing that actually match us in reliability. So we're very proud of, and we will continue to maintain this standing hopefully for years to come. So for those of you that are already partners with Lenovo, this may look familiar to you, or if you're a Lenovo customer, you may have seen this before, but this is our online configuration tool, and this partnership that we have with Scale Computing, we have really fully integrated into our offerings. So Lenovo partners, Lenovo direct sellers can go in here and configure a Scale Computing solution that matches their needs, and, you know, get it quoted and turned around fairly quickly. So as you can see here from the screenshot, we've got the HE3 down there at the bottom. We are obviously taking this very seriously and integrating it directly in with the rest of our product families in the Lenovo portfolio. All right, so here you can see just some of the feedback that Scale Computing has won just from peer reviews, things like Spiceworks reviews, Gartner Peer Insights, and Trust Radius. So you can see, you know, 5 stars across the board at the top. Trust Radius 9.6 out of 10. I've been watching the chat window, seeing a lot of people say, I love Scale. I've gone to a few different events now with my colleagues from Scale. A lot of people really like this solution, and it is a great solution. So, you know, be confident that you can trust Scale with your infrastructure, and not just from those that are already using it, but there's also some top-rated different publications that are out there that are also recognizing it. So CRN has ranked Scale Computing as the #1 virtualization solution and the #1 hyperconverged solution this year. So, you know, step aside some of the bigger players in the game. You know, Scale is obviously ready to go, and you know, we'll continue growing with our partnership with Lenovo. So. So that kind of leads us to the end of the presentation. If anybody has, any questions, please feel free to reach out to Mike or myself. As much as I would love to see bvioland@scalecomputing.com, that's incorrect. For me, it would be bvioland@lenovo.com. If you do have any questions, please feel to reach out to Mike and I. So with that, let me send things back over to David.
All right. Well, thank you, Mike and Brad, for your presentation and going through the demo today. I want to remind everyone you can still get some more information there in the handout section, so look for that before we finish up. And also, you can still get those questions in while we're kind of closing out here. If you can get some in, we can definitely throw them over to Mike and Brad. Another reminder is we are posting the winner of the contest into the attendee chat, so look for that there. We'll also have that information posted in the community in the contest page. Also reminders, you can view this on demand, so you'll get that link in about a day, and if you missed any portion of this or need to review it, you can look for that link and view it at your convenience. Okay, so let's look here in the questions before we finish, see if we have anything. Someone's asking about a training program. I don't know if that's something, Mike or Brad, that you can answer.
So it looks like, do we still have Mike with us? So I know within Lenovo we do not have any current training. Oh, so is it trade-in program?
Trade-in program.
So it's a trade-in program. So I know with Lenovo we currently don't have a trade-in program in place, but if Mike's still on, or if any of the Scale guys can throw in the chat window maybe, I'm not sure if they have anything currently.
Okay, well, we can certainly follow up with that. Another question here from Ben. How does a micro data center compare to a normal data center?
So with that, the way that I would characterize it is, you're going to have a lot of the same challenges, right? As you would with a normal data center, except that a lot of times the idea of a micro data center is you're going to have less staff or sometimes no staff on site to be able to maintain it. So it needs to be able to manage remotely very easily, and be very simple and not a lot of components, have redundancy built in, things like that. So that's kind of my take on micro versus a normal data center. But Mike did have to jump off early. He had another call that he had to get ready for. So we can also follow up with him offline and get his take on it as well.
All right. Well, with that, we'll go ahead and close up today. Thank you, everyone, for attending. We'll look forward to another partner webinar with all of you soon. And until then, stay safe and keep it spicy. Take care, everyone.